Hello, in this session we will discuss about lattice energy and His law of constant heat of summation. So first of all, lattice energy. So what is meant by lattice energy? It is related to the crystalline substances, it is related to the ionic substances. So what is the lattice energy? We will see the definition. The amount of energy released, it is the amount of energy released, very important one, energy released. So it is an exothermic. The amount of energy released when required number of oppositely charged gaseous ions present at infinite distance and comes to form 1 mole of an ionic crystalline solid. So it is an energy released when infinite distance comes closer and form 1 mole of crystalline substances. So sodium ion and chlorine ion that are present in the gaseous state at infinite distance. But what happened? When they are comes closer and forming 1 mole of crystalline substances, this energy is released, that is minus 782.82 kilojoule per mole. So this energy is called as lattice energy of substance, and it is directly proportional to the charges on cation and anion. So that is Z plus and Z minus. So this is charges on ions, Z plus and Z minus, which is called as charges on ions, and Rc plus and Ra minus. So this is radius of cation. This is radius of cation, and R minus A. This is the radius of an ion. This is radius of cation, and this is the radius of an ion. So this is your lattice energy. Next point, His law for constant heat of summation. So it is depending on several steps or enthalpy related to the reactions. So enthalpy of reaction means if you are observing the energy curve of reactant, so each and every one molecule has some amount of energy. Each and every one atom molecule has some amount of energy. If reactant is converted into the product in any reaction, reactant is converted into the product in any reaction, so at that time this energy will be observed. So this is your reactant energy and this is your reaction progress. Reactant energy, this is your product energy. So whatever the energy difference will be there from product to reactant, product energy minus reactant energy, that energy is called as enthalpy of reaction. So that energy is called as enthalpy of reaction. So we will discuss this reaction, we will discuss this concept on the basis of enthalpy denoted by delta H. So what His law says that? His law says that the heat energy released or absorbed, the heat energy is released or absorbed in a chemical process. Heat energy is released or absorbed in the chemical process. It is same whether the reaction takes place or whether the reaction process occur in one step or in a several step. So heat energy is absorbed or released. It is the same whether the reaction occurs in one step or similar a number of steps. We will see the example. If A is converted into the C, via B, means first of all A is converted into the B, B is converted into the C, it means that A is converted into what? A is converted into the C. So the energy required for this process is H1, energy required for this process is H2, so that is the enthalpy. So when you are drawing the triangle, A is converted into the C via B, it means that initially this process is there, or you can directly convert into this one. So whatever the enthalpy reaction for H1 and H2, so what is the enthalpy S3? Enthalpy S3, it is always summation of H1 and H2. Enthalpy change H1 for process 1, enthalpy change S2 for process 2. And this concept is explained by the scientist His, called as His law for constant heat of summation. What is that? Enthalpy required for the reaction or the energy released or absorbed in the reaction, it is said whether the reaction takes place in one step or whether the reaction takes place in n number of steps. So the next concept on the basis of lattice energy, His law and Born-Haber cycle. So this is lattice energy and His law gives Born-Haber cycle. So Born-Haber is the scientist who gives the formation of sodium chloride crystal from their atoms. So we will discuss one by one. What is Hess law? We have already discussed Hess law. Hess law is called as, Hess law states that energy or enthalpy released in the process or absorbed in the process, it is same whether the reaction takes place in n number of steps or whether the reaction takes place in single one step. So this is single one step. Sodium chloride gives, sodium atom and chlorine gives sodium chloride. This is single one step. It requires minus 410.5 kilojoule energy. And in n number of steps, so what energy we will require, that we will calculate with the help of this single one step. So we will discuss one by one. First of all, sodium chloride is formed by sodium gas atom, sodium gas ion and chlorine gas ion. So sodium gas ion and chlorine gas ion shows electrostatic force of interaction to form sodium chloride. But how these ions are formed, we will discuss from one by one. First of all, so the first reaction is, or first process is sublimation process, or the reaction is called as enthalpy of sublimation. Energy related to this one. First one, enthalpy of sublimation. So what is the enthalpy of sublimation? Sublimation is what? Solid substance is directly converted from solid state to the gaseous state. So sodium solid, actually sodium exists in solid state in atmosphere. So that solid state sodium changes its state from sodium state in gaseous. So this is called as directly solid does not loses electron to form ion. So first of all we are converting solid into the gaseous one and then we are losing that electron. So the enthalpy related to this process is called as enthalpy of sublimation. Enthalpy of sublimation stands for S. Enthalpy of sublimation is 108.7 kilojoule per mole. In a second process, what we are dealing? Ionization we are dealing. So enthalpy of ionization. So what is ionization? Sodium gas substance loses one electron. And form sodium gas to the sodium gas ion. By losing one electron, it carries an plus one charge. So energy involved in this process is delta H is equals to 492.82 kilojoule per mole. So this is your second energy. Third one. So this is your first complete process from formation of sodium solid to the sodium gas ion species. So in the second one, directly chlorine does not react. Initially, it is present in diatomic state by the Avogadro's rule. Any gaseous substance are present in di, tri, tetraatomic state except halogens. Except noble gases in the periodic table. They are exist in the monatomic state. So the chlorine exists in diatomic state. So molecular state to the atom, single one atom. So this is called as atomization energy. So what is the atomization energy of chlorine? So chlorine 1/2 Cl2 that changes into the Cl. Two single separate atoms will be formed in this process. That is atomization energy. So the enthalpy regarding to this one is 119.55 kilojoule per mole. And the last one, this electron lost by the sodium, and in this process electron is lost by the sodium and that electron is absorbed by the second chlorine. So that is called as electron gain enthalpy. So what is the electron gain enthalpy in this reaction? So chlorine gas absorb that electron of sodium and form chlorine ion in gaseous state. So the enthalpy released in this process is minus 361.60. So we have studied about Born-Haber cycle. So Born-Haber cycle, it gives sodium chloride formation in crystal state. From sodium solid to sodium and sodium gas. First of all, the enthalpy is required, that is H1, H2, H3, H4. H1, H2, H3 and H4, and enthalpy of reaction, that is, sorry, lattice energy of reaction. So when you are taking addition of all these four, you are taking addition of all these fours, the energy required for these four, it will be same energy of this number. It will be a same energy of these numbers. So what is the enthalpy of formation of this reaction? Enthalpy of formation of this crystal is 410.5. First step, second step, third step, fourth step require any energy, and this is your lattice and energy of crystal for formation of 1 mole molecule. So that will be the value of minus 769.5 minus 769.45 kilojoule per mole. So when you are substituting this value here, you will get 410 value. It means that, so whether the reaction takes place n number of step and single one step, the energy required will be same. Next concept, lattice energy of crystal. So first of all, it is factors affecting lattice energy or factors influenced by the lattice energy. As the size of cation anion decreases, lattice energy increases. We know that very smaller substance is there, at that time energy required for breaking the substance is very high. Same here, lithium, sodium and potassium. Out of these three compounds, potassium substance is larger in the size than the lithium, sodium and then the lithium. So as smaller substance is there, energy required is larger. It means that it having higher lattice energy than this one, So out of these four crystal, comparison of anion is there. Comparison of fluorine, chlorine, bromine, iodine is there. So fluorine is smaller in size, or this substance is smaller in size as compared to the lithium iodide. So the energy required for breaking is also high, or lattice energy of this compound is very also high. Second point, greater is the charge on ion, more is the lattice energy. So aluminum nitride 3 plus 3 plus, 2 plus 2 plus, 1 plus 1 plus. So larger is the charge, more is the electrostatic force of interaction, and greater is the lattice energy of crystal. Third, divalent, monovalent, and monovalent. So comparison about this one. So divalent having higher lattice energy than this one and then this one. So this is the comparison of lattice energy, and this is depending on transfer of electron. This is directly transfer electron to one atom, two atom, single electron transfer. So when you are discussing about lattice energy, so when lattice energy is higher for any substance or greater for any substance, the bond is more and more stronger, and it shows higher stability of compound. When bond is stronger, at that time stability of compound will be enhances, and melting point also enhances. But due to the stability, this compound has low solubility in any solvent. So this is your lattice energy, Bohr-Haber cycle and Hess law.